This video is going to cover metals, nonmetals, and metalloids. One of the ways that we can classify elements on the periodic table is as a metal, a nonmetal, or a metalloid. The metalloids are the dividing line between the metals and the nonmetals. So you can see here, there's a stair step going down. If you're touching that stair step, those are your metalloids, and here they are highlighted in this bluish color. Everything to the left of the metalloids is a metal, with the exception of hydrogen. Everything to the right of the metalloids is a nonmetal. So do note that even though hydrogen appears here on the periodic table, it is a nonmetal. This particular table also labels increasing metallic character for you. So the general trend is that the further to the bottom left on the periodic table, the more metallic character that you have. So what makes something a metal? Metals tend to form cations. That means a metal is going to be more likely to give away electrons and take on a positive charge. And so you see that on the periodic table. Everything to the left of the metalloids tends to take a positive charge. Nonmetals are the opposite. They tend to form anions, so they're going to accept electrons and take a negative charge. And then you have your noble gases. These are nonmetals, but they generally don't take any charge. You can see here your trends in charge. Everything in group 1 tends to have a charge of +1. Group 2 is +2. Group 3 is generally +3. Skip across to here, your nonmetals. This group is -3, -2, -1. And then here in the middle, your transition metals can take multiple charges. So a lot of times you see like iron can be +2 or +3. Most of what we find in nature is made up of compounds. But of the elements that are found as pure elements in nature, they're usually metals. Here are some properties of metals. Metals are shiny, so we say that they have luster. Metals are good conductors of heat and electricity. Metals are malleable, which means you can bend them. Metals are ductile, meaning you can draw them into wires. Metals are solid at room temperature. Mercury is the exception to that. Mercury is a liquid. And we saw in our previous video that metals have low ionization energies. So that means it doesn't take very much energy for a metal to lose an electron, which explains why they're more likely to become cations and take a positive charge. Of all of the trends that we looked at on the periodic table, ionization energy is the one that helps us predict whether or not something will be a metal or a nonmetal, because that helps us to predict how easily you can take an electron away from this atom. A few notes about how metals react with other elements. When you have a metal and a nonmetal together in a compound, that tends to be an ionic compound. We also talk a lot about metal oxides because oxygen is so available in our atmosphere that metal oxides are pretty common. Metal oxides are basic in nature. And what I mean by that, when you dissolve a metal oxide in water, it tends to form a metal hydroxide. And a base is defined as something that gives off hydroxide in solution. So your metal oxides, when dissolved in water, tend to be basic. The other way that metal oxides demonstrate their basic nature is by neutralizing an acid. So here's an example where you have a metal oxide plus nitric acid, and it's forming an ionic salt, so an ionic compound, plus water. This is a neutralization reaction where you combine something with acid and it neutralizes to form a salt plus water. Let's switch gears and talk a little about nonmetals. Nonmetals are found on the right-hand side of the periodic table. Whereas we said that metals are usually solid at room temperature, nonmetals can be solid, liquid, or gas, depending on the element. If they are solid, they're usually dull. They usually are brittle, which means that they're going to break easy. They're not going to bend the way a metal does. And they're usually poor conductors. So you see that these are opposites of metals. Nonmetals tend to become anions, so they tend to accept electrons and take a negative charge. Let's talk a little about how nonmetals react with other elements. We said just a minute ago that when you have a metal and a nonmetal, that's an ionic compound, like sodium and chloride. Ionic compounds are it's a series of ions held together by positive and negative charges. So an ionic compound, when you see the formula, like 1 sodium and 1 chlorine, that's a ratio. These things are in a 1-to-1 ratio. When you only have nonmetals, they tend to be molecular compounds. Molecular compounds, the formula tells you the actual number of atoms present. It's not a ratio. So water is 1 oxygen and 2 hydrogens. So a metal and a nonmetal, you're going to get this ionic compound. For 2 nonmetals, you're going to get molecules, which are discrete units. When a nonmetal reacts with oxygen, like carbon dioxide, if you dissolve that in water, it tends to form an acid. So carbon dioxide plus water is going to form carbonic acid. That's an acid because it can give away hydrogens in solution. Table 7.3 in your textbook does a good job of outlining the properties of metals and nonmetals. Your metalloids fall in between metals and nonmetals. They have some properties of metals and some properties of nonmetals. Silicon, for example, is shiny like a metal, but it's not a very good conductor like a nonmetal, and it's brittle like a nonmetal. Some of your metalloids, like silicon, make good semiconductors. In their pure form, they don't conduct electricity very well, but if you add particles to them, you can control how much electricity that they will conduct, and that makes them very useful when you're designing computer chips.